All right, so here's our new content for today. We've been working with equations of quadratics that are in standard form, and we've been working with equations of quadratics that are in factored form. The question is, how do we get from from standard form to factored form? So we already know how to go from factored form to standard form, right? We do that by distribution. So here's an example. We have x times x plus 7. So we use the distributive property to do x times x and get x squared, and x times 7 to get 7x. Here they're asking us to do the reverse. They want us to go from x squared plus 9 back to factored form. So if we use this first step as an example, you can see the thing that's different from x squared plus 9 and x squared plus 7x is the 7 became a 9. So in my example then, it should be true that if I change the 7 to a 9 and make this x plus 9, when I do the distributive property, I should get x squared plus 9x. X times x is x squared, x times 9 is 9x. So I'm really looking for what two things were being multiplied to get my final answer. So if I break this down, I had x squared plus 9x. I want to look for what these two terms have in common. So this term is x times x, and this term is 9 times x. What is the common factor in each of those terms? Well, they each have an x in common. So what we do is we take that x out, and then we write what's left in the parenthesis. So when I take this x out, this x is left. When I took this x out, this 9 was left. And that's how I got to my answer of x times x plus 9. So we can do something similar here for x squared minus 8x. X squared is x times x. 8x is 8 times x. So the thing they have in common is an x. And when I take out what's in common, if I take out this x, then this x is left. And if I take out this x, then this minus 8 is what's left. So that's how you factor when there are only two terms. Now let's expand that. Each parenthesis has two terms. So this is where we use the distributive property. We had x plus 6, and we wanted to multiply it by x times plus 2. And so now we have to do 4 multiplications. We have to do the x times x, the x times 2. We have to do the 6 times x and the 6 times 2. And when we do those multiplications, we get x squared plus 2x plus 6x plus 12. Then we have a step here where we have to combine these two middle terms to get our 8x. So we have x squared plus 8x plus 12 as our final answer over here. So I'm going to write that in here. X squared plus 8x plus 12. But let's go back and look at where each of these numbers came from. The 12 here came from multiplying the 6 times the 2. Right, so this 12 here in our final answer was 6 times 2. This 8 here came from adding 6 plus 2, right here, 6 plus 2. So to get to this standard form, that means the last number was some two numbers multiplied together, and the middle term was those same two numbers added together. So let's see what happens here when we try to work backwards. We need the numbers for 12 that will multiply to 12. So 1 times 12, 2 times 6, and 3 times 4. All of those pairs multiply to 12. Our goal is to find the pair, though, that will combine to give us 13. Yep, right here, 1 and 12. So those are the numbers we're going to put in our parentheses. We're going to have x plus 1 and x plus 12. And then we check and see, is 1 plus 12 13? Yes. Is 1 times 12 12? Yes. All right, I'm going to leave this one for you to do because it's distribution again. And we're going to take a jump down here and look at this problem. I still want two numbers that multiply to 12, so I can still use these pairs. But this time I need the middle number to become a 7. So which of the pairs can I make a 7 out of? Yeah, right here, 3 and 4. Now, if I just do plus 3 and plus 4, I'm going to get a positive 7. So if I want it to be negative 7, I have to use negative 3 and negative 4. So my parentheses are going to be x minus 3, x minus 4. All right, so these next 4 examples, notice that they all have a plus 9 at the end. So we need the numbers that multiply to 9. And we only have 2 choices. We have 1 times 9, and we have 3 times 3. So we're going to come up with 4 different answers using these same factors so that we get 4 different middle terms. And that's going to help you see how we get from a positive to a negative. So in this one, I want the 2 numbers that will add to 6. Well, 3 and 3 add to 6. So here I'm going to have x plus 3, x plus 3. Right? 3 times 3 is 9. 3 plus 3 is 6. That's good. But down here we have a negative 6. So what happens to these 3's in order to make it a negative 6? Right, we change it to x minus 3 and x minus 3. So the only thing that changed in these 2 problems was this went from a plus sign to a minus sign. So these go from plus signs to minus signs. So now let's take a look at these other 2. Still using 9s, we want the 2 numbers that will add to 10. Yeah, 1 and 9 add to 10. So here I'm going to have x plus 1, x plus 9. 1 times 9 is 9, 1 plus 9 is 10. Now I need it to be a negative 10, so what do I change? Right, I change the pluses to minuses. X minus 1 and x minus 9. All right, and so down here is just a generic rule. I'm looking for 2 numbers here that will multiply to give me this last constant, or C value. I'm looking for those same 2 numbers to either add or subtract to give me this middle term.